Okay, this is Matt Roscoe with just a short video to introduce to you your performance assessment task number 2 for our course M234 Higher Math for Elementary School Teachers. Sorry I can't be with you today, but I hope that you'll get a chance to gather and start on this performance assessment task. I think it'd be kind of an interesting thing to do without me in the room. So let me get you started. So the first thing to know is that the objectives for this second, unit in our course are already posted. I won't go through each of the objectives. I will tell you that the objectives are listed here on the second page of the PAT. You're going to be asked to find and use factors and multiples, to explain the common divisibility tests, to understand and use prime and composite numbers, and then to display your knowledge of the real number system. So those are kind of the targets. You should go and read each one of those so that you understand them more fully. But let's go ahead and just get started with the PAT, describing it, and so that you'll have a chance to do some things in class together tomorrow. So I'll just read through it here. Number theory is all about the multiplicative structure of the integers. Number theory asks questions about divisors and multiples. Number theory classifies integers as either prime or composite or neither. And it looks into multiplicative structure by finding these prime factorizations. Let's look at some examples of these types of questions by choosing two numbers. Let's compare 42 and 72. And below might be a list of number theory questions we could ask. So what's the list of all the divisors for each number? How could I find each list efficiently? How can we quickly see if either of the numbers is divisible by 2, 3, 4, 5, 6, 8, 9, or 10? Are there any common divisors? Which one is the greatest common divisor? How are all the divisors related to the greatest common divisor? What about multiples? What are some multiples of each number, and how can I find them? Do the two numbers share any multiples? What are they, and what is the least of these common multiples? Is either number prime, or are both composite? What's each number's prime factorization, and how does this make transparent some of the answers to the questions we've asked above? And then finally, what if I use the two numbers in a fraction to make a rational number? How do the answers to the questions above inform the fractional representation written in lowest terms? What if I computed the fraction as a decimal? Will the representation terminate or repeat? And if it does repeat, how long might the repetend be? How do the answers above help me predict this? So just to preview, in the activity, you're going to be given a number, and you're asked to compare your number to every other number in the class by asking all the questions above for each pairing. There are 10 students in the course, so that means 9 different comparisons. Each comparison should take a single page. The numbers that you've been assigned are found below. Present the results of the activity as a demonstration of your mathematical ability in number theory, and a rubric is provided on the next page of the document. So you can see that I've given each of you a number, and you're going to compare your number, much like I will here in a second, with 42 and 72 to every other number in the class. So you're going to carry out 9 different comparisons. So let's go ahead and take a look at how this might work for 42 and 72. So let's start out with 42 on the left here. The first thing we were asked to do is to think about factors of the number. So we can quickly make a factor list by listing numbers. I can see that 1 and 42 would be factors. I can see by quickly using a divisibility test that this is divisible by 2, so 2 and 21. I can also see that it's divisible by 3 using a divisibility test. It's 3, and let's see, 3 goes in 4 once, and 3 and 14. Is that right? Yeah. Let's see, 4 does not go into the number, 5 does not go into the number, 6 does go into the number, it's 6 times 7, and then I know I can stop right there. We'll talk about that later, but this would be the complete list of factor pairs for the number, or all the factors of 42. So I'll just write factors. Let's see, so we were going to also do 72. So again, listing factors, I would start with 1 and 72. I can see 2 will divide it. That'll be 36. I can use a divisibility test to say that 3 will divide it as well. The way I'm doing that is by just looking at the sum of the digits. 7 plus 2 makes 9, and 9 is divisible by 3. So 3 will divide 72. That's called the divisibility test, and we'll learn about that in the chapter on divisibility. Let's see, 3 goes into there twice. Twice, leaving 12, so 3 times 24 it looks like. I can see that 4 also will go into the number, so let's see, 4 goes in there once, 32 left over, so 4 goes into 32 8 times. Let's see, 5 doesn't divide it, but 6 will. I can see that 6 will have to divide it because 2 and 3 divide it, right? So let's see, 6 goes in there once with 12 remaining, so 12. 6 times 12, yep. Let's see, 7 goes in there. Yeah, it does. No, it doesn't. 7 doesn't go in there, but 8 does go in there. It's 8 times 9. And I know I can stop right there. The reason I know is because the next factor will be greater than 9, and we've already checked. So it's, I guess, pair will be less than 9, and we've already checked everything less than 9. Okay, so there's 72, and there's 42. What would be the greatest common factor? Let's see. So I guess let's do common factors first. So definitely they share a common factor of 1. They share a common factor of 2 and 3. They don't share 4, but they do share 6. They share 8, no. 9, no. 12, 18. Looks like that's it. 1, 2, 3, and 6. So 6 is the greatest common factor. So I guess I can write down that the greatest common factor is equal to 6. What about multiples? So let's look at multiples next. Let's see. So if I started out with 42, multiple of 42 would be, let's see, 42, 84. Let me get my calculator out really quick. Just type some things in. So using my calculator, I can get a table of these really kind of quickly. So I typed in 42x into my graphing calculator, get 4284, and gone to the table 126, 168, 210, 252, 294, 336, 378. That's probably enough just to get us started. Let's take a look at 72's multiples. 72, 144. Let's see, I'm going to do this in my graphing calculator again. 72x, and then I'm going to go to the table. So let's see, 216, 288, 363, 432, 504, 576. I don't know. Let's see, 648. Yeah, it doesn't look like we have them, any common multiples yet, do we? But I know that there must be a common multiple, right? So maybe I'll just move this one down. Lost a couple commas, but we can fix that. Let's see. 378 would be followed by 462, 504, 546. Oh, there's one. 504, 546. And I think we just got one, right? So 504, I'll go ahead and highlight that green. 504 is definitely a common multiple. Does anybody see any others? let's just make sure here. 84, 126, 168, 210, 252, 294, 336, 378, 420, 462. Okay. Yeah, I think that's the first one. It'd be interesting to see when the next one would be in the list. But we've definitely found the least common multiple, it looks like. It's 504. Okay. So let's see, what have we done so far? We found the divisors of the number. We found the common divisor, the greatest common divisors. I didn't really answer the question, how are all the divisors related to the greatest common divisor, but maybe you can see that here. All of the divisors are related to the common divisor, the greatest common factor, or greatest common divisor of 6. What about multiples? We found some multiples. Do the two numbers share? Yeah, they do. We found one. Maybe we would find a couple more. And we definitely have found the least one. Is either number prime or are both composite? And what is each number's prime factorization? Okay, let's do that. Well, as we can see, that neither of the numbers is prime because they have more than just 2 divisors. That's the definition of prime. Prime numbers are those numbers which have only or have exactly 2 divisors, one in themselves. So let's go ahead and do the prime factorization for 42 over here. So let's see, 42 we can call 2 times 21. 21 we can call 3 times 7. And that's the prime factorization of 42. In other words, 42 is equal to 2 times 3 times 7. Let's do the same thing for 72. 72, 8 times 9, 4 times 2, 3 times 3, 2 times 2. So again, once we get to the end of the branches, we can see that the prime factorization here is going to be 2 to the 3rd times 3 squared, or 2 times 2 times 2 times 3 times 3. And maybe it's easier to see it that way, 2 times 2 times 2 times 3 times 3. And then one of the questions that's asked is, how does this make transparent some of the things that we did up here above? One of the things that makes immediately transparent to me is greatest common divisor. I don't know if you're noticing this at all, but I noticed that the things that they share in their prime factorization are a 2 and a 3. Another thing I notice that's kind of interesting is that this, what's left over, I don't know, this number is 7, and what's left over here would be 2 2s and a 3, which together would make a 12 if you multiplied them. And it seems like that has something to do with multiples. In 72, if I kind of look at it carefully, there is a 7 that pops out to me there, and in 42 there is a 12 that pops out there too. Maybe we'll talk about that more when we get to the chapter on greatest common factor, but what's left when I pull out the greatest common factor seems to have something to do with 1, 2, 3, 4, 5, 6, 7, and something to do with 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Interesting. Okay, well, number theory, right? Mysterious. So it seems like we figured out that both of them are composite and that those factorizations do help us see some things. And then the last piece is, what if I wrote it in a fraction? How did the answers to the question above inform the fractional representation written in lowest terms? Okay, well, let's go ahead and add one more page here and talk about that. So if I take a look at 42, well, if I took a look at 42 70-seconds, well, then I can say that's the same thing as, let's see, if I 2 times 21 over 2 times 36, right? which would be the same thing as 2136. The reason that's the case is because this is just a smart form of 1, so I can take any 1s out. But that's also got a factor of 3 to it, so it would be 3 times 7 over 3 times 12, which is, again, one of these smart forms of 1. So I can call this 7/12, right? So written in lowest terms, 42/72 is the same thing as 7/12. But the thing, I don't know if you noticed this, but the thing that we pulled out was, if we kind of think of it carefully, this is what we really did, is we had 6 times 7 over 6 times 12 that we canceled, right? And of course, that's exactly the 7/12 that we get over to the right. And the thing that we happen to cancel here turns out to be the GCD, right? The GCD of 42 and 72 is found there and there, right? Yeah, so what we're effectively doing when we find the fraction written in lowest terms is canceling the greatest common divisor, which is one of the big reasons why we study it in elementary grades, is because it's useful to us for fractions. Okay, and then the big question is, well, how about what does this thing look like as a decimal? So I'd ask you right now to just ask yourself, do you think this decimal will terminate or will it repeat? Can you predict that, right? I'm going to type it into my calculator and just see what I get. And here's what I get for a decimal: 0.583 repeating. So this one does indeed repeat infinitely, so it does not terminate. And if you said this one won't terminate, you were correct. And it turns out that all rational numbers rational numbers are any number that can be written as a fraction, that they'll either terminate or repeat. But one of the things we'll learn about is how to predict this. And I can tell you that I could have predicted this fairly quickly by thinking about the number 12, what we're dividing by. There's certain property of fractions that some of them terminate and some of them repeat. And we'll learn about that in our studies, but if you already know that or if you want to explore that, that's something you could do. So this is generally what I would like you to do for each one of the pairs of numbers. And hopefully when you get together tomorrow, you will have a chance to carry out 2 or 3 of these in this same fashion. You might not be able to get everything done, and you probably won't be able to know how to predict whether the fraction will terminate or repeat unless you look it up. But most of this you should be able to at least get a good start on Friday. I guess I will just leave it at that, ask you to gather together on Friday, and I'll come in on Monday and just ask you how many of you were present to count you for attendance on Friday. So I do encourage you to come. You will get credit for attendance if you do come, and you'll get a head start on the PAT. All right. Well, that's it for now. I hope you have a great weekend, and we'll see you all on Monday when I get back. Good luck, everyone. Stay warm.